Today we're on page 34 of our note guide, solving polynomial equations in factored form. The first thing we want to talk about is writing equations in standard form versus factored form. A polynomial is in factored form when it is written as a product of factors. When you hear the word product just means multiplication. So if it's in factored form, we have two things that are multiplied together, whereas standard form has pluses and minuses. So if I have standard form, which is x squared plus 2x, that is x squared plus 2x, whereas if we write it in factored form, we have x multiplied by x plus 2. X squared plus 5x minus 24 is equal to x minus 3 times x plus 8. So we have two things that are multiplied in factored form, and all of them are added in standard form. When one side of a polynomial is in factored form and the other side is 0, we're going to use the zero product property to solve the equation. If we have the solution of a polynomial equation, those are also called zeros or roots. So sometimes it will say find the zeros or find the roots or find the solutions of a polynomial, and all of those mean the same thing. Now, if I were to take a star and times it by 0, that would equal 0 because anything times 0 equals 0. If I were to take a heart and times it by a star and say that equals 0, and I were told that the heart is equal to 3, well, if that heart is equal to 3 and it's timed by a star to equal 0, that would tell me that the star would have to equal 0 because 3 times 0 equals 0. So let's try one more. If I were told that a square times a triangle equals 0, and then I was told that that square is equal to 8, the triangle would have to equal 0 because 8 times 0 equals 0. So let's look over at this zero product property. If I am told that A times B equals 0, then either my A has to equal 0 or my B has to equal 0. So let's look at number 1. I have two things that are multiplied together. I have x, and that is multiplied by an x minus 1. So since we have two things that are multiplying together to equal 0, then either the x has to equal 0 or the x minus 1 has to equal 0. Now we're going to solve both these for x. If we look at x equals 0, that's already solved for x. We can't do anything to that. Whereas the x minus 1, we can add 1 to both sides, and we get x equals 1. Now if I were to check this, I could put 0 times 0 minus 1, if we plug 0 into this equation. 0 times negative 1 gives me 0. If I put a 1 in, I have 1 times 1 minus 1 equals 0. 1 times 0 equals 0. So no matter which one I pick, they will give me 0 in the end if I have x equals 0 or x equals 1. We have, on number 2, we have two things multiplied to equal 0. We have 3t could equal 0, or t plus 2 could equal 0. We're going to solve each one of these for t, divide both sides by 3, and t equals 0. 0 divided by 3 is 0. If I minus 2 from both sides of the equal sign, I get t equals negative 2. And no matter which one I put into the equation, we will still get the answer of 0. If I put 3 times 0 for the first part, and 0 plus 2 inside the parentheses, if we plug the 0 in, we get 3 times 0 times 2. And anything times 0 is going to equal 0. Now if we put a negative 2 in, 3 times negative 2 times negative 2 plus 2. Negative 2 plus 2 gives us 0. And 3 times negative 2 times 0 is all going to equal 0. Looking at number 3, we're going to set both of these equal to 0. So either 7 minus 4 has to equal 0, or z minus 6 has to equal 0. So we're going to add 4 to both sides of the equal sign, and z will equal 4. On the other equation, we're going to add 6 to both sides of the equal sign. And so z will equal 6 there. So my two answers are going to be z equals 4 or z equals 6. Let's plug this in so we can see why this works. If I plug 4 into the equation everywhere there's a z, I get 4 minus 4 and 4 minus 6. 4 minus 4 is 0, and 4 minus 6 is negative 2. And 0 times negative 2 equals 0. If I plug 6 into the original equation, I have 6 minus 4 for the first parenthesis, and 6 minus 6 for the second parenthesis. 6 minus 4 gives us 2, and 6 minus 6 is 0. Well, 2 times 0 equals 0. On number 4, we have 2x plus 7 and 2x minus 7 equals 0 if we multiply those together. So since they're multiplied, we can say 2x plus 7 equals 0, or 2x minus 7 equals 0. To solve this for x, we subtract 7 on both sides of the equal sign, and we get 2x equals negative 7. We divide both sides by 2, and x will equal negative 7 over 2, or negative 3.5. On the other side, on the other equation, we're going to add 7 to both sides, so we get 2x equals 7, and we divide by 2, and x will equal positive 3.5 there. Looking at number 5, we have x minus 1 squared. Now, if you remember, x minus 1 squared is equal to x minus 1 times x minus 1. We have two things that are set equal to 0, x minus 1 equals 0, or x minus 1 equals 0. Well, these two are the exact same thing. So we can add 1 to both sides of the equal sign, x equals 1, and the other equation is the same, where we get x plus 1 again. So since those answers are the same, that is my only solution, where x is equal to 1. Let's look at number 6. We have x plus 1 times x minus 3 times x minus 2 equals 0. So we're going to have 3 equations this time. One of those 3 factors have to be equal to 0 for this whole thing to be equal to 0. So x plus 1 equals 0, or x minus 3 equals 0, or x minus 2 equals 0. So what we're going to do is we're going to subtract 1 from both sides on the first equation, add 3 to both sides for the second equation, and add 2 to both sides for the third equation. So x equals 2. So we have 3 answers: x equals negative 1, x equals 3, or x equals 2. And all 3 of those, when you plug them in, will set one of those factors equal to 0. If I put a negative 1 in, it'll make that first one 0. If I put a 3 in, it will make the second parenthesis set 0. And if I put a 2 in, it will make the third set 0. The next section talks about factoring polynomials using the greatest common factor. To solve a polynomial equation using the zero product property, we need to get it in factored form so we can set each piece equal to 0. You may need to factor the polynomial. Factoring reverses the distributive property. So we look for the greatest common factor. This is a monomial that divides evenly into each term. So on number 7, we are finding the greatest common factor, or the GCF, of the two numbers. So the GCF is the biggest number that will divide into both numbers. So I'm going to make a factor tree of 18. I have 2 times 3 times 3 gives us 18. 9 and 5 are 45, and 3 and 3 make 9. So we have 2 3's on both of our numbers, so we're going to multiply those to be 9. So 9 goes evenly into both 18 and 45. 6 and 6 goes into 36. We're going to break that each 6 down to 2 and 3. So we have 2 times 3 and 2 times 3. 24, I have 6 times 4, and 6 breaks down to 2 and 3, and 4 breaks down to 2 and 2. So each set has 2 sets of 2's. We have 2 2's on 36 and 2 2's on the 24. They both have a 3 in common as well. Now the 36 has an extra 3 and the 24 has an extra 2. But what we're going to do is we're going to take those factors that are the same and multiply them together. 2 times 2 times 3 gives us 12. Let's look at number 9. We want to think of the biggest number that goes into 5, -10, and -15. So 5 goes into 5, 10, and 15. So if I take the 5 out of the first term, the only thing that is left is the x squared. So 5 times x squared, when we distribute it, gives us 5x squared. On the second one, we're looking for a number that multiplies to give us a -10. 5 times -2 gives us -10, but we need an x, so we have -10x. 5 times -3 gives us -15. So this would be the factored form of 5x squared minus 10x minus 15. On number 10, 8 and 24. Well, I want to look at that 8. 8 will go into both 8 and 24. And then we have y squared and y. The first one has 2 y's and the second one has a y. They both have a y that will go in evenly. So my greatest common factor is going to be that 8y. So 8y times y gives me 8y squared, and 8y times -3 gives me -24y. This would be the factored form by taking out the greatest common factor. Now 8 and 20, I'm going to break down 8 to be 4 and 2 and 2 and 2. 20 is 2 times 10, and 10 breaks down to 2 and 5. Well, they both have 2 2's. 2 times 2 is 4. So we're going to bring that 4 out. Now I have 3 x's for the first term and 2 x's for the second. Both of them have 2 x's. So we're going to factor out 4x squared. Now I'm looking for what times 4x squared gives me 8x cubed. 4 times 2 gives me 8, and x squared times x gives me x cubed when I distribute that. 4 times 5 gives me 20, and 4x squared times 5 gives me that 20x squared that we're looking for up top. On number 12, I have 5x cubed minus 3x squared. Looking at 5 and 3, there's not really a number that goes into both 5 and 3, but 1 will go into any number. So if there's not a number that goes into both of them, just put a 1. So the first half has x cubed. We have x times x times x, and the second one has x times x. Both of them have 2 x's. So we're going to pull the x squared out. X squared times 5x will give me 5x cubed, and x squared times a -3 will give me -3x squared. So when we write our answer, we don't need to put the 1 on the front. We will just end up with x squared times 5x minus 3. On number 13, we are solving the equation. So we have a squared plus 5a. We're going to take a out. Both of them have an a in common. We're going to take that out, and then we write what's left. A times a gives us a squared, and then we're thinking what times a will give us 5a? Well, that will be a 5. So we're going to add up plus 5 to the second set of parentheses, and that's going to equal 0. Well, now we use the zero product property to write a equals 0 or a plus 5 equals 0. A plus 0 is done. We don't need to, that's just the answer. But we do need to solve for a in the second equation. We're going to minus 5 from both sides of the equal sign, and a will equal a negative 5. And both of these answers will give us 0 at the end. If I plug 0 in, 0 squared plus 5 times 0 equals 0. 0 plus 0 equals 0. If I put in a negative 5 squared plus 5 times a negative 5, negative 5 squared gives me 25, and 5 times negative 5 is negative 25. That equals 0, so that one checks out as well. Looking at 3x squared and negative 9x, what's the biggest number that will go into both 3 and 9? That will be 3. And then we have x squared and x. Both of them have an x in common that we pull out front. We put our parentheses, and we have 3x times x gives me 3x squared, and 3x times negative 3 gives me negative 9x. This is all equal to 0. We're going to set up two equations where we have 3x equals 0 and x minus 3 equals 0. On the first equation, we divide both sides by 3, and so x equals 0. And on the second equation, we add 3 to both sides, so x equals 3. Those will be the two answers that will make our equation 0. Now, if I plug in 0 into the original equation, I have 3 times 0 squared minus 9 times 0, and that will equal 0 minus 0, which is 0. 3 times 3 squared is 27, and negative 9 times 3 is 27. 27 minus 27 is going to give you 0 as well. So both of these answers work. Now, 15 is in the wrong form. To use the zero product property, we need to set everything equal to 0 so that we can use that. So if I have 4x squared equals 2x, what I want to do is I want to minus 2x from both sides of the equal sign. This will give me 4x squared minus 2x, and that will all be equal to 0. So next, I want to factor out the greatest common factor. 2x will go into both pieces of that equation. 2x times 2x gives me 4x squared, and 2x times a negative 1 gives me negative 2x. So I set both of these equations these pieces equal to 0. Either 2x has to equal 0 or 2x minus 1 has to equal 0. We divide both sides by 2, and x will equal 0. On the second equation, we add 1 to both sides of the equal sign. 2x equals 1. Then we divide by 2 on both sides, so x will equal 1/2. It is perfectly fine to get an answer that has a fraction in it. The last piece is we are going to write factor pairs. We always start with 1. 1 times 24 gives us 24. Then we can look at 2. 2 goes into 24 12 times. 3 goes into 24 8 times. 4 goes into 24 6 times. If we try 5, 5 won't go into 24. Our next number is 6, but since 6 is already a factor, we can stop at that number. Now, these numbers can also be negative. I could take negative 1 times negative 24, and that would give me a positive 24, as well as all of the rest of the factors. We can just change them to negative times negative, which will give us a positive number. Now, let's ignore the negative for a minute and just look at the factor pairs of 54. 1 will always go into a number, so I'm going to say 1 times 54. Then I can look at 2. 2 will go into 54 evenly because 54 is an even number. So 2 goes into 54 27 times. 3, if I add 5 plus 4, I get 9. So I know 3 will go into 54 because 3 goes into 9. 3 goes into 54 18 times. Looking at 4, 4 will not go into 54 evenly. So we're going to skip that one. 5 will not go into 54 evenly because it doesn't end in a 5 or 0. 6 does. 6 times 9 is 54. So 7 won't go into 54 and 8 won't go into 54. 9 will, but since we've already used 9, we know we're done. Now we're going to take and we're going to add the negatives to all of the first numbers. -1 times 54 gives me -54, and so on. And on the second half of the numbers, you're going to make the second half negative so that they will multiply evenly to 54.